Okay, a third example. Example 3. Okay, again for convergent, we say as n goes to infinity, comma, an goes to L. So it's a convergent sequence. So if I have something like an is equal to root n, okay, and we think about n going to infinity, well, of course, an is going to go to infinity as well. Because this square root function does not have a maximum. Okay, it doesn't have a ceiling. It just keeps on growing and growing and growing. In math, we say it's unbounded. So we say that, therefore, an is divergent. Okay, so again, no maximum here. Another example in the same vein, an is ln of n. Again, an is going to go to infinity. Now, if you think about the graph of ln of x, say f of x is equal to ln of x. Now, if you look at this arm of it, it appears that it's flattening out, but never quite flattens out. Okay, it just keeps on growing and growing and growing as you put in larger and larger x values. So, something to keep in mind. So in this case, therefore, an, the sequence is divergent as well. Example 5. Let's get some more space here. Two, so 3 minus 2n multiplied by 3 to the n. Okay, what's happening here? Well, I don't know. It's a little bit confusing, right? I think I should simplify because I can see here that the lim is infinity of this little bit here, but here the limit, equals 0. So that is a confusing situation. This is a 0 times infinity. Now we'll recall from our discussion of indeterminate forms that this is an indeterminate form. So that requires further investigation. So what I'll do is I'll simplify. I'll write this as 2 cubed for 2 to the 2n times 3n. And then what? Well, that's going to be 8 over 4 to the n times 3 to the n, because 2 to the 2n, that's 2 squared to the n, which is 4 to the n. Little thought cloud over here. And then what do I get? I get 8 times 3 over 4 to the n. Okay, this is a bit easier to look at. And what can I conclude? Well, let me see. 3 over 4 is less than 1, right? So let's call this R. And we can see that R is less than 1. It's bigger than 0. Now, if you have an R like this, if you have a fraction, 3 over 4, and you think about what's happening to it, as you take higher and higher powers, well, what's happening is this is getting smaller and smaller. In fact, you can get as small as you want. Another way to think about it is to think about 3 over 4 as 0.75. Okay. So when you multiply by 0.75, you're taking, it's like taking 75%. So as I go further and further along here, I'm taking 75% each time, and then I'm taking 75% of 75%, and then 75% of 75% of 75%, and I keep on getting smaller and smaller. And the question is, how small do I get? Or maybe better said is there any limit to how small I can get? And the answer is no. The answer is yes, right? The answer is yes. I do indeed go to 0. And in fact, I can get as close to 0 as I want. So you can try it on your calculator. You can say to yourself, okay, I want this item here to be less than 1 over a million. Now, I think if you play around, you'll be able to find an n that will make that happen for you. Now, let's say I want to make this expression less than 1 over a billion. It's going to be possible to find a very large n that will make that happen. Okay, all this to say, therefore, n is convergent. Okay, in general, if you have a, remember we called this fraction r. If you have an r, and r is between -1 that will give r to the n a sequence that goes to 0. Okay, so if you have a real number between -1 and 1, strictly between -1 and 1, then r to the n is a sequence that will go to 0.